Good morning. Today we're going to show how to take this drawing of a package and a die and put them into a program called Tagger and Wirebond to generate a Wirebond document. Wirebond and Tagger both work by adding intelligence to an AutoCAD drawing, which really has no intelligence associated with it. So there is a little bit of setup time. The intent of a program like Tagger is that you only need to add the intelligence to the package drawing once. Then you can reuse that new intelligent drawing over and over again as you put different die into the package. We don't normally start with the die already in the package because our assumption is that they're coming from two different sources. The package from the original package designer and the die from the chip designers. The first thing we're going to do is look at this drawing and see what we want to change. Let's start with the die. Let's just hover over this entity, and it tells us that's a polyline. That's good. That's the die outline. This is the die pad, which is a polyline. That's okay. If we zoom in even farther, then we'll see that there's a net name on its own layer. That's also quite good. However, when I say AutoCAD's not intelligent, I mean that this net name and this pad are not tied together in any way. So if one selects this pad, one doesn't really know that that's the net name. So one of the things we'll be doing with Tagger or Wirebond is to make that association. We'll also find the center of the pad, because you can see that this polyline does not have a center with it, and we'll assign a die pad number to it. And you can see here there's a number 1 next to this pad, so that we know that this is number 1. Typically then we would number these counterclockwise. I have to remove this from the drawing and process it separately, and I'm going to do that using the wblock command. I'm going to type in wblock. We're going to select the objects and we're going to delete it from this drawing here. We don't need it. Let's select the objects. I'm going to use a window selection from here to here, and I hit enter. Now I have to give it a name, so let's call it test die. Click OK. It disappears because I told it to delete it. At this point we're going to save this and close it, and then we're going to go to test die and we're going to create our AIF file that we need. I've opened the test die drawing we created from the wblock command, and now we're going to use the module called die clean to find the die and to number them for us and to export a die net list. If we zoom in real quick, we'll see that we have the net names on a layer called 112, and we have our die outline and we have our die pads. Use either Tagger's die clean or we can use Wirebond's die clean. They're both the same. So let's use Tagger die clean. You can see that what it did was it went in and it found what it thought were the die, and it's put an X on each one. It also is guessing that this is pin 1, which is in fact correct. Now we have to define the size of the die. The way you would normally do that is you would either type it in or you would pick the die rectangles, and I'm going to do that by zooming in here and clicking there and then zooming to the other corner and picking that spot. You see I get 1170. I'm going to get rid of the change. We don't need it. So that's the size of our die outline. Now I have to decide how I'm going to label the die pads. For the pad numbers, I wanted to start at pin 1, so that's our pin 1. We're going to number these counterclockwise, so this will be 2, 3, 4, all the way around. But for the net names, we're going to say use layer 1112 and associate the text on that layer with the pad that it's nearest. We'll just click OK. It just takes a few seconds, and now it's done. Let's look at what we generated. And we can see it created this right now. It tells us it's AIF, and it tells it's in microns because I told it it was in microns. It picks up the size of the die. There's only one pad it found. It actually finds each pad and makes it into like a pad stack. And then here's our net list. So this was the net it found. This is the die pad number. This is the pad stack. And this is the coordinates. For every single die pad, there is a net, coordinates, and a pad stack. And that's what we call an AIF file, and that's what the input to Wirebond is.